I'm sorry, I forgot to mention the most important thing about the first assignment, which is how to actually write a scanner. So I'm going to talk about that. And also I wanted to mention that for all of the course, you can use whichever programming language you want to implement Simplang. We had the poll on Slack where a majority voted for me using C. So we'll see how that goes. But by the way, if anybody is very uncomfortable with me implementing it in C, then please tell me and we'll find some other solution. But whatever you're using is fine. So let's talk about scanners. As you can see in Simplang, the lexical analysis is relatively easy because there's not that many things to take into account. So what scanners usually do is they proceed linearly from one character to the next. So you would start at the beginning of the file, and you also, by the way, you can totally read in the whole file as a string first, and then just work in the string, you know, whichever works best for you. But you start at the beginning of the file, and you look at a character. If it's a white space character and you just started scanning, then you want to ignore it, so you skip ahead. And white space just means space or tab or new line, or most programming languages have something in their library where you can ask, is this character white space? So then at some point you end up at a non-white space character, which must be the beginning of a token. And beginning of a token means it's either a letter, in which case the token that you're reading might be a keyword or an identifier. It could also be an underscore, in which case it must be an identifier. Or it's one of those characters, open paren, close paren, or equal one of these, then it's an operator. Or it's a digit, in which case it's an integer. So you kind of already know what you're reading. So you proceed and you try to read as many characters as you can without slipping into a new token. So for example, if you know that your token is a keyword or an identifier, you just skip ahead as long as you're reading letters or numbers or underscores. So once you hit white space, your token is complete. Or once you hit something that's not a digit or a letter or an underscore, as in this case, once you hit the plus, you know your identifier is complete. And then the only thing you have to do is figure out, is it a keyword or is it an identifier? So you know where your token starts, you know where it ends. So, you know, you can get the whole text of the token, and then you go like, well, is it a let, is it let, is it end, is it in, is it if? If it's one of those, then obviously it's a keyword. Otherwise, it's an identifier. In this case, it's an identifier. And the one thing that you need to be mindful of is that you need to make sure that you're not skipping over characters that are after the ends of your token. So basically you need to look ahead one character, and then that character is going to be potentially the first one that is going to be the first in the next token. So if I scan an identifier here, start with the A, so the A is fine. I'm skipping, you know, I remember where the A was, and then I go like, okay, let's look at the next one. The G, I know it's going to be also part of the identifier. The J also, the H, the G, the H, the J, But then I look ahead and I see a plus, and I go like, okay, I cannot consume the plus. I'll keep the plus for the next token, but I'm done now. Does that make sense?
Do we store the information if the identifier already exists or not? Or do we just ignore that for now?
No, that is the thing that the parser takes care of.
Okay.
The scanner doesn't need to know anything other than what the token type is, and if it's an identifier or an integer, what the value is.
Okay, yeah.
Because if you did that, then, for example, so this is just hypothetical, right? But if the scanner, for example, took note that there's an A here, so now I know the A, right? So this A is the same as this A, which is fine. But then in examples further down, for example, you can have stuff like you can rebind. You can introduce a new variable with the same name, but it's actually different, right? So this A is a different A than this one, right? Does that make sense?
Yeah.
So it wouldn't help the parser in any way to know that these two are connected in any way, because they're really not. They just have the same name, but they're different variables.
Okay.
Gokul, does that make things clear? Okay. I should maybe also mention, just as a theoretical aside, on how scanner generators generate scanners. So in a scanner generator like Flex, for example, Flex. Oh, should have looked that up before. Like software. Okay. So what you give a scanner generator like Lex is a set of regular expressions, each of which match one of your token types. And a simple regular expression would be, for example, just let for the keyword let. And what the scanner generator does is it will generate a state machine that can scan this that can scan your scanner grammar, and it will then generate a large table of state machine transitions. And the state machine, let's say our should do it here. Let's say we have a scanner grammar, like we only generate, or we only accept the keyword let, and we accept let's say we also accept integers, and we accept identifiers that consist of digits, just of letters, right? And so the machine would start in state 0, which is the initial state, and then it would have state transitions for the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say they go to state 1, And so state 1 is the so state 1 is the integer scanner. Of course, the scanner doesn't give names to the states. And what the integer scanner does is, as long as it sees more integers, it goes back to state number 1. So it keeps scanning, but it is also a final state that produces integer, which means that if it sees anything other than an integer, it will say, I'm done, and what you get is the token type integer, right? Now, it's more complicated with this because it's possible that let might be a keyword or it might be an identifier. By the way, I'm not saying you should write the scanner like this. I'm just trying to tell you how an automatic scanner generator would do that. And this is an identifier. So if we see any letter that is not L, any letter not L, then we can go to, let's say, state number 2, and state number 2 is the identifier scanner. And the identifier scanner would go any letter, keep scanning an identifier, right? But also, if there's no more letters, we're done. Identifier. But then also, if you see an L, go to state number 3. And here it gets kind of a little bit complicated, or not really complicated, but this is the let scanner that has just seen an L. So if the let scanner sees an E, it goes to state number 4, because it might still be a let. But if it's not an L, if it's any other letter, then it goes back, or it doesn't go back, but it goes to scanner state 2, which means that it is an identifier, and we can just keep scanning an identifier. So in state number 4, we have a let, and we've seen L and E, right? So if we see a T, we go to state number 5. And if we see any other letter, again, we know it's an identifier, it's not a let. And in state number 5, we have seen the whole let, and it's a final state let. So there's nothing for us to scan anymore. We can't accept anything. Now, actually, what you usually also do, you tell the scanner that you ignore white space, right? So if I told it, wait, what was that? No. So if I told the scanner to ignore white space, so something like that, then what it also has to do, at least at the beginning of a token, maybe it would also do it at the end of the token, but I don't want to go that far. But it would actually have to start in, let's say, state -1, white space. Actually, no. The init state would say, as long as we see white space, we're still in the init state, right? And now the scanner generator would actually, yes, this would be a finite state machine. You don't even need a stack or anything. So I could actually now implement this. Design is created, yes. I could implement this in very simple C. I could say I have my global state, which starts with 0, right? And I have my function scan. And what I do is I switch over the state. And if my state is 0, then course, I should probably, so this I do forever, obviously, and then I say int next equals next character. Let's call it n. And now I have to say if is space n, then actually I don't do anything. And to continue, I'm going to say, no, just break. If is digit n, then what I'm doing is state equals 1. So I'm basically just doing what the state machine specification says, right? I'm going to state number 1, and I do break. If it is L, if n equals L, state equals 3, break. And not need L. And if it's any other letter, then state equals 2, break. And anything else means that there's an error, right? So let's just say scan error, because it's not specified. So I can actually detect errors. And so I don't actually need the breaks, except for whatever. And I would just continue doing that until I'm done with all the states. And at the end, I just fetch one character after the next. And then obviously, like, so for example, in let's say in state number 1, if it's a digit, and then I don't do anything, my state is still 1. But if it's anything else, then I can return that it is an integer. Right? However, the problem is I've now already consumed the next token. So actually what I have to do is I would have to do a look ahead, right? So I'm not consuming the token. I'm not consuming the character. I'm just doing a look ahead. And in any case where I actually do a state transition, either to this state or to another, I would have to actually consume the character. And the only case where I don't consume the character is, so I would consume here, I would consume there. Here I would consume, but it would not consume in the case where I don't actually change the state, because this means that I'm done, and when I read start scanning again, I need to look at that character again. Are consume and look ahead library functions in C? No, I mean, kind of. If you read with, I think, fgetC. So fgetC will give you one. Oh, and by the way, you also have to handle the case where you're at the end of the file, right? So I'm assuming that look ahead would give you, like, let's say -1 in case you're at the end of the file. What was I gonna say? Yes, so fgetC will give you the next character, and I think it will actually give you -1 in case of, oh no, it will give you eoff. It will give you eoff in case of end of file. And then you can use f, what is it called? F, there's a function that puts it back. F unget. No. Damn. C F get C put back. Unget C. F unget C is probably what it's called. Oh no. Unget C. Yeah, so consistently named. So with unget C, you can actually push back a character onto a stream. So you can implement look ahead as look ahead. You implement look ahead as character equals f get C from the stream. No, so f put C puts it writes a character. It doesn't put it back to the reader. If C equals E off, then of course return C. Otherwise, you want to unget C file and return C. We've consumed it, and then we've told the reader, actually, and the next time you give us a character, give us this one again. And consume would just do fget C. But of course, you can also read the whole file into a string and just index into it if you want. Okay. All right. Any other questions?
How difficult would it be to implement it by state machines? Because if we have like 10 or 15 keywords, there would be a whole lot of states, right?
Yeah, that's why I'm saying don't implement it like this. Right? This is not, I'm not advocating that you implement it like this. I'm saying a scanner generator, like an automatic scanner generator, would generate a state machine like this.
Okay.
Hello?
Yeah.
I'm sorry if I missed anything in the last video, but why is there a need to represent it as a finite state machine?
Again, I'm not saying you should implement the scanner as a state machine. I talked about how you should do it before that. I'm saying if you use the scanner generator like Flex, the scanner generator would generate a state machine like that.
Oh, okay. Oh, that makes sense. Thank you.
Yeah, this was just a theoretical or semi-theoretical aside. I'm sorry if that was confusing.
Oh, no, that's fine. And do you recommend any book for compiler theory or any which is based on practical stuff rather than theoretical?
I'll have to look at that, at like what the latest literature is. I do remember there is modern compiler implementation, which I do remember being quite good, but that was quite a long time ago. I don't know if there's any more modern books. Yes, there's the Dragon book. The Dragon book is very old.
Yeah, that's old and that's tough as hell. I've heard about it. It takes too far.
So I'm not saying the Dragon book is bad. The Dragon book is just heavy on
Theoretical stuff?
On kind of like, how should I put it? A lot of stuff that there's a lot of theory, for example, there's a lot of theory and practice on parsing and scanning. That was much more important back in the day when computers were super, super slow and you wanted a scanner and a parser that was really, really fast. So it has all the theory on how to generate these state machines. It has all the theory on how to generate the state machines for parsers. Then there's even lots of theory about how you can make a parser that will automatically correct errors by inserting the minimum amount of tokens and stuff like that. But then on the other hand, there's, for example, no modern stuff like, it doesn't talk about SSA because S is a static single assignment form, which was not invented back then. I don't know if it has anything on, it doesn't have the modern register allocation stuff like a standard modern one is the linear scan register allocator. So that's why I'm a little hesitant. Let me look at the table of contents. Register allocation, yeah. Yeah, and then for example, it's not going to have anything. It doesn't have anything about how to integrate with garbage collectors, how object-oriented programming languages are implemented, because those weren't invented back then. No polymorphic stuff, no SSA. I don't know if it has scheduling, although scheduling these days is not super important anymore. Yeah. So if it were a choice between the two, I would rather recommend modern compiler implementation. Pick your favorite. But I'll take a look at it. Maybe there's something even better right now. But I can definitely recommend.
Okay. Thank you.
Anything else? All right, then let's hope I haven't forgotten any other stuff this time. And yeah, I'll talk to you soon. Bye.